So good afternoon everybody, this is Acharya Vishvendra and today I'm gonna speak on NCERT questions. So let's start with chapter number 7 which is rigid body itself. So let's start with the question. So initially we have questions based on particle, extended body, rigid body. Then we have perfectly rigid bodies. Then we have questions on pure translational motion, rolls without slipping. Then we have movement of particles. Then we have rotation of a top problem, then axis of rotation. Then we have rotational motion. Then we have a projectile motion. Then we have problems related to the position of the center of mass of a system of particles in different systems. Then we have position vector of center of mass. Then numericals based on coordinates of center of mass. Then we have a triangular problem based on center of mass. Then we have a lamina based problem on the center of mass, then a general problem in vector form. Then we have the concept of velocity of center of mass. Then a numerical problem based on the velocity of center of mass. Then we need to find the speed of center of mass of the body. Then we have n particles problem and we need to find acceleration of the center of mass of the system. Then we are being given a question, we are being given coordinates of a particle. We need to find initial position, then center of mass, and then velocity and acceleration of the center of mass. Then we need to find about internal and external forces. Then we are being given a question on trajectory of a bomb. Then internal external forces. Then we are being given a momentum time graph. And we need to find external force at different instants. Then we are being given a question on oblique collision of two particles. Then we are being given a question based on explosion of heavy nuclei. Then we are being given a binary star system, and we need to find the location of their movement as per the frame of center of mass. Next is vector product. So we are being asked some properties of vector product. Then the direction of the vector product. Then right hand screw rule. Then we have questions based on some properties of the cross product. Then we are being given a numerical based on two vectors, and we are being asked their magnitudes, a vector, b vector, then a root b, then a cross b. Then a numerical problem on that. Two vectors are given. We need to find magnitudes of two vectors, their dot product, components, cross product, the magnitude of cross product. Then we are being given a question on rotation of a rigid body, and we need to find the angular speed of the rigid body, then angular velocity, then linear speed, then axis of rotation. Then we have a condition for pure rotation motion. Then we have linear velocity, angular velocity relation. Then we have a dimension formula for angular acceleration, average and instantaneous acceleration. Then we are being given a numerical based on angular displacement and find angular position. Then angular velocity, instantaneous and at a given instant, speed, then momentum, then initial momentum, then instantaneous force. In the next question, we are being given angular momentum. We need to find initial angular momentum, torque, initial torque. Then we are being given a question on angular momentum versus time, and we need to find torque at different instants. Then we need are being asked a question based on angular momentum and torque. Then there is a question on metal bar suspended by two masses. So we need to find reaction forces. Then we have a ladder problem, and we need to find normal reaction, friction. Then about the center of mass and center of gravity. Then we have a question based on numerical problem based on the lever principle based on of moments. Then we have load arm, effort, then mechanical advantage. Then we need to find moment of inertia, radius of gyration and different points. Then we have parallel and perpendicular axis theorems. Then we have translational and rotational equilibrium. Then we have the conditions for translation and rotational equilibrium. Then we have angular momentum. Then a question based on force and position vector. We are being asked force, magnitude, torque, magnitude of torque, torque about another point whose position vector is given, then magnitude of torque. Then we are being given a question which is about a particle moving along a straight line with a certain speed, and x coordinate increases with time, the graph of that is given. We need to find the equation of trajectory, velocity, angular momentum, conditions on angular momentum, direction, conditions for mechanical equilibrium. Then we have the conditions of mechanical equilibrium of the system. Then we are being given a question based on angular velocity versus time. We are being asked angular acceleration at t is equal to 2 seconds, then 4 seconds, then at 8 seconds. Then we are being asked about moment of force. Then we are being asked about torque. Then conditions for maximum and minimum torque, which is 0. Then magnitude of torque. Then component relation and torque. Then a numerical problem on the torque. Then component about along a certain line perpendicular to the line and the torque. Then another numerical on force and position vector. We need to find torque. Then torque about x-axis, y-axis and z-axis. Then we are being asked dimensional formula for torque, SI unit, moment of force, on reversing the direction of force, impact on torque. Then impact of reversing the direction of force in the position vector both. Then we are being asked rotation analogous of mass, force, momentum, impulse, then dimensional formula of all of these. Then angular momentum, its magnitude, conditions for maximum and minimum. Then angular momentum magnitude, then direction. Then we have torque and angular momentum. Then we are being given a mass and position vector. We need to find initial position vector, work done by tension, rotational motion, angular momentum, constant conditions, then acrobat, then rolling without slipping, then instantaneous axis of rotation, then work done in rotational motion, then power in rotational motion, then tension in the string, angular acceleration, parallel and perpendicular axis theorems. Then we have moment of inertia about different axes. Then a problem on dimensional units of moment of inertia. Then graph of moment of inertia, its variation, numerical problem based on that. Then we have pure rolling on inclined plane, speed, acceleration, time taken, then total energy, speed, maximum, minima, acceleration, maximum, minima, translation, kinetic energy, maximum, minima, rotational kinetic energy, maximum, minima. So there are a total of 279 questions in this particular chapter, and these are sufficient for preparing you optimally for NEET physics, your school physics and your JEE Main physics. So I hope it will prove to be a boon to you in making your fundamentals crystal clear and can help you in optimizing your performance. Thank you. Have a nice day.